In this video, we will conduct a simple XYZ analysis in Power Query with Microsoft Excel. We will work with a file that has more than 1 million rows, so that means we cannot open it in stock Excel, so that we have to use Power Query if we want to use Excel at all. And this is how it works. So we go to the Data tab, we connect to a data source. Here we choose from text CSV because our data is stored in a CSV file. Then I navigate to my folder in which I have stored the test data. All right, so here I get a preview of my data. Power Query suggests a specific encoding, which is Western European in this case. This is correct. It suggests a delimiter, which is in this case a semicolon, and this all looks very good. Now, importantly, we do not want to import all the data into an Excel sheet, so we have to click on this downward pointing arrow and select Load To, because what we want to do is we want to simply create a connection to the data source. We do not want to import the data. This is very similar to working with a database where you also don't import all the data, but you only access very specific data that you request. Once we hit OK, on the right-hand side, the Queries and Connection window opens. And if we double-click on this specific query, which represents the connection to our exercise data, then the Power Query editor opens. And you can see I have 4 columns here. I've got the order date, the order ID, the item ID, and the quantity. Now, before I continue, I would like to make one change here to the data type. And I don't really need this for this example, but it would be better if we always had the correct data type for all columns at all times. So I changed this from whole number to text. Order date is fine, order ID is fine, item ID is also fine, it is text, and quantity is whole numbers. Very good. Since the XYZ analysis is a tool to investigate the variability of demand across defined time buckets, one of the first things that we have to do is to define these time buckets. Now, what are time buckets? What do I mean by that? A time bucket is a designated time unit used to segment the total observation period. In our dataset, the observation period spans slightly more than 8 months, from April to December. We aim to divide this period into equal-sized buckets to analyze how demand fluctuates across these intervals. So we can make use of the date and time functions in Power Query. But before we modify the original dataset here, I would like to create a reference to this imported table. I rename this XYZ analysis. And I select my order date column. I select the Add Column tab. Then I go to the Date button over here. And I say month, because I want to create a column that contains only the month. Alternatively, what I could do is I could create a column that contains only the calendar week. And now the question is, what is the right time bucket for an XYZ analysis? Now, of course, it depends on the situation. It depends on the questions that you want to answer. But if we look at demand, it probably makes sense in most cases to not choose the time bucket too small, because that will artificially inflate the variability. So I will choose a month as a time bucket. In other cases, a calendar week would be the better choice. Certainly a day in most cases will not be the right choice, because the variability across the days is too high to make any meaningful statistical analysis. Right, now we've got the month here. I will sort this in ascending order. This takes a while. All right. Now, one thing I can see here is that there are a couple of empty values in the order date column, and I would like to remove them. So I click on the little downward pointing arrow here and I select Remove Empty. All rows that contain a null value in the order date column will be removed. All right, very good. The next thing we want to do is we want to group by and then perform an aggregate function on the table. So In this particular case, for the XYZ analysis, we want to group by item ID and by month, or by whatever time bucket we have defined. The reason being that we want to understand the variability of demand across the different time buckets. All right, so I select the two columns and then I hit Group By in the Transform tab. And because I have selected the two columns before, I already have them here in the dialog window. If you have not selected the two columns, you have to select the right columns here in the dialog window. Okay, so if we want to conduct an XYZ analysis on order lines, then we need to count the rows. That's very simple. If we want to conduct an XYZ analysis on quantities, we have to select sum, and then we have to select the column that we want to sum, which would be quantity. But we would like to stick to order lines. All right, so then I hit OK. Then I want to sort my month column in ascending order. And now what we need to do is we need to pivot the month column, which means for each month in the month column, we would like to have a separate column. And the values below these columns will be the counted order lines that we see in the count column. If you are familiar with pivot tables in Microsoft Excel, this concept will be quite familiar to you. If not, please bear with me for a moment and you will see how it works. So I select pivot column. Then I am asked what values are supposed to go into the value columns below the month. And I would like to have my count values here. All right, so you can see we have the item ID on the left-hand side. We have for each month a separate column. And below the month number, we can see the aggregated number of order lines for each product for each month. You can see that a lot of products have not been ordered in several months, so that we have null values here. Now, one thing that we need to do is we need to replace all the null values, which are not numbers, but just mean there's nothing in here. We have to replace these null values with actual zeros, which is a number. Okay, so I select all the monthly columns. Then I go to replace values. I type null in value to find, and I want to replace this with 0. Now you can see that we do not have any null values any longer, but we have a lot of zeros here. Now the next step is already to begin to assess the variability of demand. Now, how do we assess variability? Now, there's one statistical value that we can make use of, and this one is called the coefficient of variation. The coefficient of variation is a measure that helps you understand how much variation or spread there is in a set of data. And that means relative to its mean or average value. So the coefficient of variation is calculated by dividing the standard deviation, which is a measure of spread in a data set, by the mean of the data set. This means we have to compute both the mean and the standard deviation. And in Power Query, this is very simple, since we can use the standard statistics function. So I will mark the columns here, and I will go to the Add Column tab, and then go to the statistics functions here, and I select Average, which will add a column that contains the average value for each row in the dataset. There it is. And I will do the same thing with the standard deviation. So I select the monthly columns, I go to statistics, and I select standard deviation. There we go. Now we have the average and the standard deviation. And in order to calculate the coefficient of variation, we simply have to divide the standard deviation by the average. So we go to the Add Column tab, and then we select Custom Column. The new column name will be CV for coefficient of variation. I select the standard deviation column, and this will be divided by the average column. And that's it. There we go. The last thing that remains to be done is the classification of all SKUs into X, Y, or Z. And we do this by defining boundaries between these three categories and checking for each coefficient of variation between which boundaries it falls. Alright, so let's begin by defining the boundaries. And the simplest way of defining the boundaries without hard coding them is by creating a new data table. So in the Home tab of Power Query, I go to Enter Data, and I will call this table XYZ boundaries. The first column in this new table I will call X boundary, and I will assign a value. And for the time being, that will be 1. If a coefficient of variation is smaller or equal 1, then that SKU will be classified as an X product. Then I need a Y boundary. And I will assign the value 2. All right. Now, one thing to know is that the precise boundaries, they are somewhat arbitrary. Similar to the boundaries in an ABC analysis, we can assign any boundaries that make sense for us. You will find boundaries, suggested boundaries, in the literature, but in reality, we need to check what makes sense. Because what we want to do is we want to derive decisions from the XYZ analysis, and it depends on the decisions how we set our boundaries. Now, before we introduce the conditional checks, I would like to store the two values for the X boundary and the Y boundary in, well, let's call them variables. And I can do this by creating a new reference to this table, and then I drill down into the X boundary. I rename it to X boundary, and I do the same thing for the Y boundary. New reference, rename Y boundary, and drill down. By the way, we do not need to define a Z boundary, simply because if we check for the X boundary and the Y boundary, and neither of them is kept, then it automatically needs to be a Z product. And just in case you wonder why I have defined the X boundary and the Y boundary in this dedicated data table, I would like to have one place where I can adjust my variables. So if later in the project I need to adjust the X boundary or the Y boundary, I can go to this one data table and I can adjust them. And I don't need to look up any hard-coded values anywhere. And these two variables, X boundary and Y boundary, they will be updated automatically when I update the values in the data table XYZ boundaries. And this is beautiful. So let's go ahead and add a new column to our table XYZ analysis. And we will add a custom column. This custom column we will call XYZ class. And we will introduce a very simple if check, a very simple conditional check. If our value in the CV column is less or equal X boundary, then we will return the value X, and that value X will be stored in the column XYZ class. Else, if CV is larger than Y boundary, we will return the value Z. And if that is not the case, then logically it needs to be a Y product, because then it will be in between the X boundary and the Y boundary. And that should be it. Let's try this out. Since this is a large data set, this takes a while. All right, there we go. So we have an X product here, and the coefficient of variation is less than 1. That makes sense. A Z product where the coefficient of variation is 2.3. That also makes sense. A Y product where the coefficient of variation is between 1 and 2. Yeah, so this seems to be consistent. This has worked. And this is basically it. So we have conducted a complete XYZ analysis without even doing anything in stock Excel. We've completed the analysis in Power Query. And the big advantage of that is that we are absolutely independent of the file size that we are working with. In this example, the source data had more than 2 million rows. And yes, it does take a while to process the data, even on a fast computer like this one. But that's better than not being able to do it. All right? So I hope you found this video helpful. Do let me know if you have any questions or comments. Take care and goodbye.